For our project for CSE 145, we worked on the Intelligent Camera Trap, which is an autonomous wildlife photographer, and it's used in order to gain more information and be able to observe wildlife animals in their natural habitat. So a lot of what's out there consists of cameras like these, but it can get pretty bulky, and the flash might scare away some animals, which we don't want. And it's not too cheap, so we wanted to create a more affordable solution for this. So what we've built so far is create our own camera trap using the GoPro camera, BeagleBone Black ARM processor, Trailmaster sensor, and the X10 Ninja camera turret. But the problem with this camera turret is that it's no longer being produced, which we want to be able to create more of these camera traps. We've been able to deploy in locations such as these in the local San Diego area in order to find out more about the wildlife that lives there. So our main project for the quarter was to update the turret system to make it more efficient, faster, and scalable. And the system monitoring tool that we want was in order to find out more about our deployments without actually having to be there. So for our turret system, we updated it using a high-tech winch servo controlled by BeagleBone Black and mounted on top of the GoPro camera. How we updated it is by making sure that it was available for 360-degree rotation, and the red, yellow, and green wires coming out of the chip right there is connected to a potentiometer. This potentiometer gives us readings on the current angle of the turret. And this is an example of a 90-degree input. And as you can see, the numbers on the left signify the current angle of the turret. So as you can see, it's decreasing, meaning that it's turning counterclockwise. But if it was increasing, it would mean that it's turning clockwise. And as you can see, it's connected to the board as so. So in our final product, we went from this complicated Ninja turret system that's no longer reproducible to this servo, which is a lot faster and a lot more efficient. For our system monitoring, we use the Texas Instrument INA 169 current shunt monitor, which gives us a current and a voltage reading that the battery is supplying. And we use voltage dividers to connect to our BeagleBone Black in order to gain the current and voltage being consumed by the battery. So for our turret demo, we wanted to be able to show that it can turn 180 degrees, and it's speed sensitive based on it slows down as it approaches the target, turns faster for larger rotations, and remains stable at all times.
As you can see, the camera trap begins to locate and track its object. Currently, we have it restricted to a 180-degree panning motion, although that can easily be reconfigured for a full 360-degree rotation. Here we see the camera trap tracking Jason, then momentarily begins tracking a new individual who enters into the frame. However, once it detects that the new moving object is no longer within bounds, it resumes locating and tracking a new object.